So everybody, welcome to our Introduction to Networks meeting. Let's start off. First off, do you have any questions you would like for me to try to answer before we get started? Any issues?
Questions.
Okay. I want to go over one thing real quickly that, and it's not Python Programming Essentials in Python, although that is a good course. I do want to go over, you will see in your modules for our class, you will see an item called the hands-on test or the skills final. So down here, ITC hands-on final due December 3rd. Right now, there's not a way for you to upload your hands-on assignment here, but I'm going to change that. I'm going to actually make this a submission, so an online submission, so you can upload files, and then you can upload your finished document. But it's very important, this hands-on skills exam must be completed on our NetLabs system. So when you go over here to our NetLabs system, netlabs.stanley.edu, which most of you are doing work on right now, and you do a lab reservation. So I'm going to schedule a lab for myself. If you go into our course, and yes, I am actually in this many courses as an instructor, believe it or not. But as you get into our course, you will see this item right here, and that is the skills assessment. This, ladies and gentlemen, is the hands-on test. So over here, our hands-on skills exam, this is this lab right here. So you go to netlabs.stanley.edu, you log in, and you schedule it like any other lab. Now, I'm going to go ahead and schedule this. Now, you'll notice that the labs are starting to be used a great deal more now. So it's the end of the semester, so be aware of that. Don't forget, though, to click this little right arrow, because you'll notice pods 1 through 4 have all these reservations on it. You go over to pod 5, there's not much. Pod 6, there's not much. And you get out here to pod 9, 10, and 11, and things are definitely much less in use. Don't forget, you can also go forward and schedule in the future if you need to. So if you know you want to do your hands-on test on Saturday, you could do that. But I'm going to go out here right now and find me a pod 12. And I'm going to do a reservation here, clicking on the red line, which means start right now. I am only going to set it for, I'm going to set it for 2 hours, 41 minutes, but I'll end my reservation. So I want to get this started up and letting it boot. The hands-on test, as I will show you here in just a second, is this skills assessment lab that you must schedule for yourself. All right. So the CCNA ITN skills assessment. I'm going to show you that again as this is booting. I'm going to go in here. I'm going to go to schedule lab for myself. I'm going to go to our class. You won't have these 75,000 classes. You probably will only have one, but you will see this skills assessment multi-device pod, MDP. So click this and find yourself a set time. I would say schedule at least 2 hours. And in fact, I'd go ahead and schedule 3 just for ease of use. But give yourself 2 to 3 hours, because remember, it does take about 10 to 15, I'd say about 10 minutes for everything to boot up fully in the pod. So this is what you're going to be working on. So it is in fact a router, a switch, and 2 PCs. If we look here, these 2 PCs should probably already be almost booted, which they almost are. But the routers and switch are just getting started booting. So it's going to take a little while for those two to boot. In the content, this is the basic content here that you have. As you read along, it may say have an item checked by your instructor and then move on. This instructor sign off, don't worry about that. You just complete the lab and move forward. It is very important, however, that you do this right here as part 1. It says develop an IP addressing scheme. And it says your instructor will assign one of the IPv4 networks from below. I am assigning to you the 192.168.10.0/24 network. So you need to subnet this network for a subnet A that can support 100 hosts and a subnet B that can support 50 hosts. And then you will fill out these charts, okay, as it asks. Assign the first IP address in each subnet to the router interface. Assign the last subnet in each subnet to the PC. So it's very specific on what it wants. Okay. So in part 1, you are to use the 192.168.10.0/24 network for your work. The rest of it is pretty self-explanatory. Okay. It's pretty easy for you to see what you've got to do here. You've got to do some Here's creating 2 subnets using a /48. Okay, so IPv6, you've already got your /48, so you've got your 16 bits that you'll use for that. So just be aware that this is what the hands-on test is. So when you see this, you complete it on NetLabs. You then can upload your completed document into Netacad with this assignment, or you can just email it to me, either one, or do both, and that will be fine. Okay, so that is the hands-on test mentioned down here as being due on December 3rd. You have a practice skills assessment you can do that is a packet tracer that will let you prepare for the hands-on skills exam. You will also have to do a course feedback, which will be turned on for you by December 6th. And then there's a written final exam that is due no later than December 7th. Okay. Now, granted, again, I've mentioned several of you, if we go past the end date of this class a little bit, we're not going to have a heart attack. That's just the dates that we're shooting for. If you're not going to be hit December 7th, just let me know, and we'll go from there. One of the problems I do have, though, is the final exam can only be turned on for 7 days at a time. So I will start turning it on in probably the last week. I've actually turned it on once already for one of your classmates, but I'll start turning it on with the last 2 to 3 weeks to go in class every week. So if anybody wants to complete it ahead of time, they can. But if you were to go try right now to take the final exam, you couldn't take it because it's not activated. And that's something that we need to talk about as one of our class items, and I will teach you this. We're not going to do it today, but inside of Netacad, you actually have you have to turn on exams using the assessment center, and I'll show you that later. I'm not going to show you that today. Okay. So any questions about this hands-on? And by the way, if you ever get this, device R1 is ignoring your input because the system is performing an automated operation. That means the NetLab system is still in control of this device and is working to get it up and going. Now, like here, this one, I've already got control of the switch. So when I hit enter, I get the switch and I have full control of the switch. Okay. But R1 is still booting. So just be aware of that. And it will finish up here in just a little bit and be able to get in there. So any questions about the hands-on final, which is the skills assessment in NetLabs?
No questions.
Okay. All righty. Well, let's jump over.
No, I'm good.
Okay, let's jump back over here and just real quickly, quick review of last week. We talked about transport layer, and we talked about at the transport layer, we have TCP, which is the transport layer protocol that supports reliable guaranteed delivery using sequence numbers, windowing, and retransmissions. And then we talked about UDP, which is its unreliable little brother, and which does not support any of those connection-oriented types of communication. Quick question for either one of you, Ken or Jonathan, and I think somebody else snuck in here. Who else we got just come in? We've got Matthew. Okay. Quick question for all of you. What was the mechanism used by TCP to establish a connection before trying to send information between two hosts?
Three-way handshake.
The three-way handshake. So we've got the three-way handshake, which allows us to do our guaranteed reliable delivery. Excellent. Now, all of these exist at layer 4, so our transport layer. Well, above this, we have our application layer. And this is where we're getting into the application, presentation, and session layers and the nebulous functions of the presentation and the session layers. So we're going to look at what the application layer is, and really that's why you see it wrapped up in the TCP/IP model as just the application layer instead of the application, presentation, and session layer. We'll look at peer-to-peer applications, web applications, and then some of our different services and IP addressing and file sharing services. So here we have our different layers. And again, you'll notice that in the OSI model, we do have the application, presentation, and session layers. And by definition, when we look through these, we would say the session layer was responsible for establishing, maintaining, and terminating sessions between hosts or communications between hosts. The presentation layer was responsible for converting data into an intermediary format. And the application layer was responsible for providing the needed services to any applications. Because the presentation and the session layer are kind of again, a nebulous type of layer, and there's not really even exact protocols at those layers. In the TCP/IP model, all of that was lumped into just the application layer. Some of our applications that we use are DNS. So in other words, IP address to domain name resolution, hypertext transfer protocol, HTTP, SMTP, POP, DHCP, FTP, and ICMP, or IMAP, not ICMP, but IMAP, Internet Message Access Protocol. These are all access layer protocols that are part of the TCP/IP suite. And we're going to talk about a couple of these. But you'll notice here, they talk about the presentation layer. This is some of the intermediary formats. So believe it or not, GIFs and JPEGs, PNG, those are all different formats that would be considered as part of the presentation layer. And then the session layer, I love it. It maintains a dialogue, and there are not even any protocols here. So the session layer is probably the most nebulous or undefined layer of the OSI model, because it really just talks about initiating dialogues, active and restarts. I think one of the things to think about the session layer is think about back when we had dial-up connections, when we were actually doing true dial-up with, oh, help me out here, folks, PPP. With PPP, dialing in, if you ever had an old dial-in internet connection, you had to dial in, establish a connection, you had to maintain it while you were on, and then terminate it when it was over. That was and is some of the different processes that would have been controlled by a session layer protocol. We don't really do dial-up much anymore. We may have PPPoE or point-to-point over Ethernet to do authentication on our DSL lines, but dial-up has kind of gone the way of the dinosaur.
I thought SMB is a session layer as well. Is that correct?
I would say SMB is considered a session layer protocol. You will see it sometimes called an application. But yes, SMB performs a lot of the same, performs the same functions as a session layer, but many times when you read about it, they will call it just an application protocol because they're looking at it from the TCP/IP model instead of the OSI model. So, but SMB would definitely be an example. And you could probably say that NFS would be one, or at least NFS would be more an application layer protocol. I agree with you. I would say, to me, yes, session layer SMB is one, but you do see it sometimes listed as in different formats. And we'll talk a little bit about SMB as we go down to the file sharing services, and we'll show that. DNS, this one is pretty well known. You put in www.cheese.com or www.stanley.edu or netlabs.stanley.edu, and you get your link. So this is converted to an IP address and by a DNS lookup. We got a router here. Somebody's going to end my reservation, so this pod will become available for a student. By the way, whenever you're done with a lab, if you're not using it, make sure you end your reservation just so you can make it available for other students. DHCP, which is an extension of BootP, or the Bootstrap protocol. Actually, it's a precursor to DHCP, would be the Bootstrap protocol that used to be used for diskless workstations to get their own IP address. Now we use DHCP so that we can dynamically grab our IP addresses and release them. Email protocols, SMTP, Supplemental Transfer Protocol uses TCP/25. This allows clients to send email to a mail server. POP allows you to retrieve mail from the mail server, typically downloads the entire mail to the local application. And then IMAP lets you retrieve, but you typically use and maintain the mail on the email server. Now, by default, that's what IMAP does. There are all kinds of ways to make IMAP pull down your mail too, but that's the primary difference between POP3 and IMAP. Question? Okay. FTP and TFTP. FTP is the reliable version using TCP port 20 and 21. TFTP uses UDP 69, and the big thing about TFTP is it has to have some type of upper layer application error checking if it's going to have error checking. And then in web, we all know about HTTP and HTTPS. So these are our big ones. And these would probably be, if I was going to memorize like protocol and port numbers, these would be the ones I would remember, would be these 5 right here. All right. So peer-to-peer, we talked a little bit about this, talk about peer-to-peer networks and how we do things such as torrents. Many networks now, or they block BitTorrents, and that's kind of a shame because many times we get our open source software through BitTorrents. But a peer-to-peer application allows a device to act as both a client and a server. So it's just like a peer-to-peer network. In fact, this is a peer-to-peer network right here, as opposed to a server-based network. Real quick, tell me one of the advantages of peer-to-peer networks. This is all the way back from the very first chapter, I do believe. What's an advantage of a peer-to-peer network? So let's go to open up Notepad here, folks.
Security.
Peer-to-peer advantages. You say security was an advantage. I would say just the opposite. It's a disadvantage with peer-to-peer. And the reason being is you have to maintain a user account on every machine and individual permissions on each machine. So on a peer-to-peer network like this, you would have to have a login on each peer with a password on each peer. And if you had that wanted to access resources on those, you would also have to have permissions set. So I would say it's less secure. So I would actually say that was a disadvantage, not an advantage. So let's go ahead and say it's less secure. What's an advantage though?
Is cost an advantage? Because obviously,
it's much cheaper.
Yeah.
Any of you bought a server lately? I bought 2 this week and I spent $25,000. So to give you an idea of what servers are running out in the real world, and that was a really good deal on the 2 servers I got. So a peer-to-peer is cheaper because you don't have that $11,000 to $14,000, $11,000 to $12,000 server sitting there in the network. By the way, that's one of the things, if you ever wonder where your money goes when you help take classes with us, is to put servers in so that we can have virtual machines that are available in our net labs and things like that, because you have to have decent servers on the back end to do that. They are cheaper. They're easy to configure. You know, they're fairly easy to configure. They are they don't require an admin, an overall admin most of the time. Okay, which makes them cheaper. Okay, the negative is they're less secure, and another negative I would say is not good for anything, not good for over 10 hosts. Okay, and of course the server-based network is more expensive, but it's much more secure. It's a little harder to configure depending upon what type of software you use. I would actually, this one is debatable. Okay. The reason being is I would say that due to the fact you've got centralized security on a client server network or a server-based network, that in some ways, I personally believe a client server network is easier to configure because you've got more centralized control. But you'll read in textbooks sometimes they consider this easier to configure because you don't have to learn a network operating system. But good, excellent. Like I said, this is all the way going back to chapter 1 pretty much. So here's some common peer-to-peer apps: BitTorrent, Direct Connect, eDonkey, Freenet. There's a bunch of different ones. We used to have, oh, what was that very first song sharing service?
Napster.
Napster, there you go. Yeah, years, and boy, my wife loved Napster. That was back when you could steal music anytime you wanted to. Oh, wait a minute, I didn't say it. You could get music anytime you wanted to. That's basically what you really were doing. You could get
the correct term is borrow it.
Yeah, you definitely could borrow it. So peer-to-peer there. Now let's look at our web and email. Again, I'm not going to spend a lot of time here because I think you're fairly familiar with this, how you bring in, put in HTTP plus the server name, and it will go look for index.html. We'll go request that page with a GET request, and then you will get the HTML coding back for that web page. Okay. All of that's controlled by the Hypertext Transport Protocol. or transfer protocol, excuse me, and HTML. And then if you need to make it secure, use HTTPS. By the way, I will tell you, this is also, they're using these get, post, put for a lot of our different types of basic programmability using net RESTful APIs. If you ever heard of a RESTful API, that's typically an API that's using HTTP type calls to pull information off of a programmable device. So kind of neat there. Oh, I do want to show y'all something real quick. Let me see if I got Word here. Y'all are the first people to see this. This is our schedule for the spring. Will be our schedule for the spring. You will see that your next class, CCNA 2, will start February 3rd, run to May 5th. Kirby Simerson is going to be your instructor for that. Kirby's a great guy, works at another community college in North Carolina. He's one of my primary other ITC instructors. And then we also are going to offer our first ever DevNet class, DevNet Associate. So if you know anybody interested in taking DevNet Associate, we will have that class in the spring. And that's the class that just came out for the new certification that's there. And then I am going to actually offer a CCNP Enterprise Core class in the spring. So I've had a lot of requests for that. So just be aware, right now you cannot register for these classes because they're not built. But I wanted each of you to know, since you're already in my classes, this is our spring 2021 schedule. As soon as it's posted, I'll let you know, and then you can contact Jana or Lydia and sign up for classes. I'm hoping, folks, that I will hear about some grants that will be available to pay for some classes for people. I have not heard anything yet. I did apply for grants, but at this moment, I don't have any grants to pay for instructor training costs. And I apologize, but we try to keep it as cheap as we can at $195.50 per class. But this is our schedule. So any questions on the schedule? Okay. Glad I could share that with you so you kind of are aware. And here we have email protocols. SMTP is used to send information between mail servers. Okay. Simple Mail Transport Protocol. And then IMAP and POP3 are used by clients. Now, the client does use SMTP to send mail to the server, to have it sent by the servers. But the IMAP and POP3 is used to retrieve information off of the server. Okay. So I'm not going to, again, spend a lot of time there. This is DNS. I think most people are fairly familiar with this. You know that this is your top level domain is actually, believe it or not, a lot of people don't know this, but when you really look at this, what you're looking at is .com, Cisco, www. So there's this root. This is actually the root, the dot, which is understood and that you don't see. So this is the root for DNS. Then the com is your top level domain. Then you've got Cisco, which is your second level, and then you've got the actual record. So this is typically, it could be an A record, or it's more than likely going to be in this case, since it's a web server, it could be a C name, which is a canonical name, which points to an A record. So this is your second level domain. And then top level domain. What are some other top level domains? What?
Gov.
.gov is one, definitely. What's another?
Mil.
.org, which is
net.
Yep. .net. There's a new one, .xxx, which we would all have been better off as network administrators if this would have been where they actually started with and put all the porn sites on one top level domain. Then you could have just blocked that one thing, but that is something that's out there. And there's all kind of other ones. There's .au for Australia. There's .jp for Japan. But the top level domain is the top level that you can then purchase second level domains off of. So Cisco is a second level domain that they purchased, just like Stanley is a second level domain for .edu. And then the www would be an actual pointer to a server or a service. Okay. Oop, we got a chat here. Sorry. Okay. .net. Yep. .net. Good, Paul. Most definitely. So that's actually when you're looking at a fully qualified domain name, there's an understood dot at the end, which is the root. And then you've got your top level, second level domain, and then the actual service, host, or device. And we can actually point to an individual device. You can do an A record, which points to a host. So when you put this in, you actually go out there and do a DNS query as a client to the DNS server. It will find out what servers are responsible for the, if it doesn't already know, it will look for the top level domains to find out who is responsible for Cisco. And then you will be sent to the DNS server that is the authoritative DNS server for that fully qualified domain name. So for this one's messing up for some reason. But here, if you're going to www.cisco.com, you would eventually be given an IP address, and that would be used by your client to create the packet to be able to go to that site. Okay. Now, different messages. An A record is for an end device, an IPv4 address. NS is the name server that is authoritative. So you actually, a lot of times, if you've ever played with DNS, you have to set the name server for a domain inside the DNS registry organization. Quadruple A's are IPv6, or quad A's are end device and IPv6. And MX are your mail exchange records. And this is one, if you've ever changed a mail exchange record, it can be a bit of a pain, because once you change it, DNS changes are not automatic. They have to propagate throughout the entire DNS system. So sometimes if you have to change your mail exchange record, your email can go down for a short amount of time. One of the big problems too with DNS is DNS wasn't designed from the beginning to be secure. And so one of the big problems is, when you type in www.bankofamerica.com, you expect that when you get a reply from your DNS server, that you're going to be sent to bankofamerica.com. And if you're not, if a hacker can some way change your DNS records by your local host, they can send you to a bogus looking site. Now, you should be able to tell that, because the site will not have a certificate registered to bankofamerica.com for HTTPS. But DNS has been an interesting problem for security for some time. Again, here's our look here, the root level domain, our top level domains, and then our second level domain, and then individual hosts. So you'd have a mail server, you'd have a FTP server, and a web server. Now, NS lookup will let you look and actually see information about the DNS address that's provided for your client, and the DNS information that your client knows. So you can actually look up who controls an organization. In this case, they're looking up the default server for Cisco, tells you what it is, and you can actually put in cisco.com, and it will tell you what server responded with the information, what the address is for that particular information, both IPv4 and in this case IPv6, and so on and so forth. Okay. Our last item we're going to look at in terms of protocol application information is DHCP, Dynamic Host Configuration Protocol. So this is how we dynamically assign IP addresses to host. I had to actually walk my wife through checking DHCP or information the other day on her PC, and I said, okay, go in there and select obtain address automatically, because that's what I thought, and that's the way it's always been. Go back here and see change adapter options. Okay, so go in here and you go to the properties, and you can see under IPv4 obtain an IP address automatically. I told her, I said, is it set to get a DHCP address or static? And she's like, it doesn't say either one of those. And I'm like, oh, that's right. Sorry. Obtain an IP address automatically, or use the following. So we can either statically assign an IP address, or we can obtain an IP address automatically. If you do this, you're going to use DHCP to get an IP address off of your local DHCP server if you have one. And when that happens, you will go through good old Aunt Dora. Okay, this is how I explain it to my students. Good old Aunt Dora. So the aunt that pinches you on the face at the family reunion says, when are you finally going to have kids? But with this, the client, when it boots, sends out a DHCP discover. Okay, so you have a DHCP discover go out. The first DHCP server, actually all DHCP servers to see that DHCP discover, send back an offer. So the client boots up, sends a discover and says, hey, I need an IP address. Are there any DHCP servers out there? The server will respond and say, yep. And here's an IP address that you can use along with options if you've set scope options for your DHCP scopes. The client will then request that address and say, hey, that's a mighty fine looking IP address. Do you mind if I use it? In which case the server will then say, yes, you can use it, and we'll send a DHCP acknowledgement. At that point, after the DHCP ACK, the client can bind that dynamic address to its IP address stack and will have an IP address on its on the machine itself. So if I go in here right now and do a CMD command prompt, I'm doing IP config /all. You should be able to see in my 37,000 different adapters here who my DHCP server is. And in my case, this tells me that my DHCP server is 192.168.254.254, which is my local router. And you'll see that my DNS server is Google 888.88. I actually have that set on my router. So, and then my address is 254.65, which is preferred. And that is what I have requested via DHCP. I'm not going to do a release renew and show you that because guess what? It would knock me off of the session we're trying to do here. So, but you can do an IP config /release to release this address, and then a renew to renew an address. Okay. You have an entire lab on DNS and those items there. So that's available. So FTP, TCP ports 2021. So you get a control connection, client opens it and asks a second port 20 for data, and the data is actually transferred on port 20. This sometimes used to cause problems with firewalls because it moved, used two ports. The request would come in first on 21 for control, and then the data request would be on 20. And so there is a thing called, I think it's controlless FTP, or there's another name for it, but it allows it to only use one port instead of use two. And then here's SMB. This is used by all Windows networking pretty much. And also SMB server message block is supported by almost every Linux variant out there via Samba. So it's used to be based, when you used to do these shares on Windows boxes, be based on WINS and on WINS naming. Now with the newer versions of Windows, since Windows 2000, it's been based upon DNS naming instead of WINS, which is old school if you know what WINS is. Okay. So here's an example of copying a file using SMB. So if you were sharing it on one host, or if you had a network share on a server, you could share that server's information. So when you right click on a folder and share it, you're using SMB to share it in a Windows operating system. Now, folks, I want to show you something, especially that's it for the application layer. So it's pretty simple, pretty easy. I'm not going to go all the way through 16 right now, but I do want to show you something very important, and that is they get into enabling SSH. Okay. I think I've already gone over this with you, but I want to make sure that you understand as we're preparing for our exams. On Cisco.com, okay, we have a section here under more for certifications. So if we go to certifications, okay, we're going to go to associate. and we're going to look for CCNA right here. All right. Under the CCNA, when you scroll down, you'll see the exam itself, which now is 200-301. You can scroll down and you can see what's in each course. Actually, I went one step too far. Okay, that's your implemented training. You actually click on the exam, not the training. So click on the exam. And under the exam, you will see your blueprint. And you have to log in, which I've already logged in. Once you're logged into Cisco. Whoops. All right, what happened here? Nope. Okay, so CCNA. We should better click on the exam. Huh. Okay. Well, the page is broke. Nope. I said, maybe if I go over here, it'd work. There it was. Well, it's not working there, but it should work there. I'm trying just to get to this blueprint. So download the exam blueprint. And when you download this exam blueprint, it will show you all the different pieces. Okay, so network fundamentals, things you need to know. But one of the things in the security fundamentals it says here is you've got to be able to configure or understand SSH, and you've got to be able to configure SSH. There's actually, expand all these so we can just do a quick SSH look. Okay, so these are all the different things that you need to know for to be able to pass the CCNA. So you need to know how to explain, and each one of these verbs tells you what level you need to know. So you know, explain what a router does. You have to explain a layer 2, layer 3 switch. Compare TCP to UDP, which we just did in our last chapter. Okay. You need to know how to, as we go down here, you've got to know how to configure a network device for remote access using SSH. So when it says configure, that's where you could actually get a simulation, or you could be asked about the commands for knowing how to do that. Okay, so be aware in this exam blueprint, you need to download this thing and make sure you know how to do these things. And that makes sure as we go forward, like in your next class, you're going to learn how to do static IPv4 and IPv6 routes. So you're going to have to be able to configure those. So as we look forward to our next chapter, we've only got 2 chapters left, just chapter 16 and 17. One of the things you've got to learn to do is actually enabling SSH. And I had a really good question come from Ken, and that was, why do I have to configure the domain name on a router? That is because when you generate these keys, the crypto keys, the domain name and the host name are used as seeds to generate the key. And so if the host name's not there, or if there's not a domain name set, then it can't generate the crypto keys. And you'll actually get an error message that says host name's not set, or domain name is not set. Please set first before trying to generate the crypto keys. All right. So be aware on those CCNA topics. Download this PDF, stick it in I've started doing things like this. I'm studying things on a OneNote. I just take a OneNote, create me a OneNote, and keep everything inside of it. So all my study materials for my different exams are in here. Here was the ones I used for CCNA 7 when I was doing things. Okay, so be aware of that. Any questions about that? I'll go over this next week, and then that's pretty much it. We're about almost done with the class, and I'll start going over some of the things you need to do to successfully run a class. So like how to create a course, how to turn exams on, the day-to-day things that you really need to learn from the orientation that we have. So are there any questions? Anybody have any questions about our content for today or anything at all?
I have a question. Okay, I just want to make sure. Well, this is Paul. Sorry, I just want to make sure I have everything clear. So you're giving us till the 31st to get everything done with Neticat. Is that right?
You will be, hold on one second.
I'm sorry, say it again.
I'm sorry, my wife was hollering up here. I had to mute myself until I was in class. Yes. Now, officially, the class will end, and you will lose access to our Canvas site on Stanley in the early December. But if you need some extra time, yeah, you've got time to finish up. So.
Okay. Okay. All right. Thank you.
You're welcome. Anybody else? Just be aware if you need to take the final, like I mentioned earlier. Yeah, I can only turn it on for 7 days. So give me if you want to take it after the class ends, give me a day or two. Email me and say, hey, I want to take it, tomorrow or the day after. Try not to say I'm gonna take it tonight. Can you turn on, by emailing me that morning? Give me a little, especially since we'll be on Christmas break. Give me a little bit of a heads up for the final. The other chapter exams will be on already.
Okay. Thank you.
You're welcome. Anybody else? Okay, I'm gonna stop the recording.